Quadratic systems. So first we want to determine whether the given point is a solution or a point of intersection of the graphs of the given system. So in order to do that, we're going to take this point, the x and y, and we're going to substitute it into each of the equations that we have and see whether it's true. So for the first one, we have 4 squared plus negative 5 squared equals 41. So 4 squared is 16, 5 squared is 25, or negative 5 squared is positive 25. And this should equal 41. 16 plus 25 is 41. So it works for this one. Now we do need to double check for the second one as well. So we'll do that also. For the y coordinate, we substitute negative 5, negative x coordinate is 4, minus 1. So we have negative 5 is equal to negative times 4 is negative 4 minus 1. Negative 5 equals negative 5. So this works as well. So the answer to this question is yes. This point is a solution of the system that we have. I want you to try example 2 and check back with me when you finish. With this second example, when you plug x and y into the first equation, you get negative 45 equals positive 45, which is not true. And then for the second one, you get 4 equals 4, which is true. So the problem is that it's not true for both of them. It has to be true for both, not just one of them. So the answer is no, this point, negative 3, 4, is not a solution to this system. Next, we want to talk about these. When you're given the graph of a system of equations, finding the solution set. So remember, solution sets from graphs are their points of intersection. So in example 1, we have 2 points of intersection, so we have 2 solutions. We're going to have, this is negative 3, negative 3, and we have the solution set 1, 2. So these are our solutions for the system. Here, we only have 1 point of intersection, so this is 2, 3 is our solution. And in this last example, we have no points of intersection, so we have no solutions. So next we're going to learn how to solve quadratic systems, and it uses the same ideas we did in solving algebraic systems from Algebra 1. There are 3 methods: substitution, linear combination, and graphing. Solving with substitution is when we have one equation that can be solved for either x or y easily. So we analyze the 2 equations and determine which equation can be easily solved for either x or y. When you look at your 2 equations, they're actually both solved for y, which is good for us because then step 2 actually doesn't matter. It says solve that equation for that variable, but in our case they're both already solved. So we want to substitute the expression into the other equation for the isolated variable. So this is what we're going to do. We're going to take this expression and substitute it in for y in the first equation. So we're actually going to set them equal to each other. X plus 3 is equal to negative x squared minus x plus 6. Now when we move into step 4 to solve this equation, this is where it differs from algebraic because we have this x squared. It's a quadratic. So we need to solve this the way we've been solving our previous quadratic equations, which is get everything on one side together and set it equal to 0. Now it doesn't matter which side you move things to, but because this is a negative x squared, I'm just going to move everything to the left side. That way when we add x squared to both sides, it's going to end up being a positive x squared. So then we also want to add an x to both sides, and we want to subtract a 6 from both sides. Now I'm going to do all of this in one step so that these are all going to cancel out. And on the left side we have x squared, x plus x is a positive 2x, positive 3 minus 6 is a negative 3, and this equals 0. Now when we're solving this quadratic, there are 2 methods you can use, factoring or the quadratic formula. If you just want to use quadratic formula every time, that's fine, you can, but we really need to get a handle on factoring. So I'm going to go ahead and solve this by factoring because it is faster. So we're going to factor this into x minus 3, or x plus 3, and x minus 1. If you need to pause and take the time to factor this by grouping, that's perfectly fine. So once we have it into these two factors, remember you want to set each one equal to 0. So x plus 3 equals 0, and then x minus 1 equals 0. So when you solve this equation, subtract 3 from both sides, and we get x equals negative 3. Here, add 1 to both sides, and we get x is equal to positive 1. Now we have two different answers for x, and we need to solve for the other variable. That means we're going to take each of these and then plug it back in. I'm going to plug it into this one because this one's a little easier to work with. We're going to substitute it in for x and find the two different values of y. So one of them is going to be y equals negative 3 plus 3, which y equals 0, and then the other one is going to be y equals 1 plus 3, where y equals 4. So then our two answers, we have negative 3, which goes with 0, and we have 1, which goes with 4. So our system of a quadratic and linear equation have two solutions. We can also use linear combination when we have equations where we can eliminate a term by adding or subtracting the two equations. So first, analyze the two equations and determine which variable has the same coefficient in both equations. So here we have an x squared, but our second one doesn't have an x squared. The second one has an x, but the first one doesn't have an x. So really the only one that we can hope to eliminate is the y. Thankfully, they both have a coefficient of 1. So then make sure everything is lined up. X squared, x, y, equal sign constant, that's fine. And then add or subtract down to eliminate one variable and create a new equation. So when we set our equal sign, now remember this is a negative y and a positive y. So we can just add to cancel those out. So these are going to cancel when we add those down. The x squared doesn't have another term to add it with. The minus 3x doesn't have another term to add with. The equal signs come down, and 5 minus 7 is negative 2. So again, we have this quadratic, so we need to get everything on one side together. So we are going to add 2 to both sides. Now on the left side we have x squared minus 3x, and then plus 2 is equal to 0. So now we're into step 4, solve the equation for the remaining variable. And again, we have the option to either solve by factoring, if it's factorable, or use the quadratic formula. And again, this one factors, so we're going to do that because it is faster. So we have x and x. This plus sign tells us that they're both going to be the same. This tells us they're both negative, and the only factors of 2 are 2 and 1. So we set each factor equal to 0. So then we get, we have to add 2 to both sides. So we get x is equal to 2, and then here add 1 to both sides. So x is equal to 1. So these are our two x values. And then we move into step 5. Substitute the x values back into the other equation to solve for the other variable. So again, I want to substitute it into the second one because it's a little less complicated without that squared. And then we get negative 3 times 2 plus y equals negative 7. This is negative 6 plus y equals negative 7. And then when you add 6 to both sides, this cancels and we have y equals negative 1. For this one, when you take 1 and substitute it back in, we have negative 3 times 1 plus y equals negative 7. So we have negative 3 plus y equals negative 7. Add 3 to both sides, and then we get y is equal to negative 4. So our final answers, I'm going to write it over here where I have some space. We have 2 with negative 1, and then we have 1 with negative 4. So again, this system has 2 solutions. When we solve quadratic systems by graphing, we're going to use this when both equations are in standard form, y equals ax squared plus bx plus c. Now, in our case, our equations are not in standard form, so we're going to take step 1, make sure both equations are written in standard form. So I'm going to go ahead and rewrite this first one. If y plus x squared plus x equals 12, then I want the y by itself. So subtract x squared from both sides, and we're going to subtract x from both sides. So again, I'm going to do this in one step. Those cancel and we're left with y. And then I'm going to write this in order in standard form, negative x squared minus x plus 12. And then I'm going to do the same for the second equation, y minus x squared minus 7x equals 12. So again, we want to add an x squared and add a 7x to both sides, so that these two terms cancel and we're left with y equals, and then write this side in standard form, x squared plus 7x plus 12. Now we have our 2 equations that we want to work with. I want you to go ahead and pause, write down steps 2 through 5 because this is calculator work and we're actually going to move over to the calculator. So after you write down these steps, come back and join me and then we'll work this out on the calculator. Okay, so let's go ahead and work this out on our calculator. First go into y equals and we're going to type in both of our equations. The first one, negative x squared minus x plus 12. And then hit enter. Then in y equals, in y2, you're going to type in your other equation, x squared plus 7x plus 12. And then we're going to hit graph. And then you see your 2 parabolas, but the problem is we have one intersection, but you can't see the other one. So this is where we need to adjust our window. You can either go into window or you can do zoom. So I'm going to zoom out, which is the third option, and it asks where do you want to zoom out. I'll just zoom out so I can get a picture of what's going on here. Now we're really far away, so I'm actually going to zoom in now, but in a specific place. So zoom in, and then if you can see your blinking spider guy, I'm going to move him kind of in the middle of the section of the graph where I want to look. So I hit enter, and then now I can see both intersections. So you're going to want to play around with the zoom to make sure you can see that. Then we want to get to the calc function. So second, trace, and then we want to calculate the intersection. So option 5. Now it's asking for the first curve and it'll ask for the second curve. So you want to get close to one of the intersections. So since we're close to here, we'll go ahead and do this one. That's the first curve, hit enter, and then move our spider guy. It's on the other graph and sort of close to the intersection. Second curve, hit enter, and then you want to guess, and then this is going to be your intersection. Now I know it says 1.084 e to the negative 13. This is going to be 0. It's extremely close to 0, so when you get something with an e, we can talk about it in class, but you should write down 0, 12 as one of your solutions, and then we're going to do this again. Second, trace, intersect, And then for the first curve, remember we want to go down towards the other intersection. So here's our first graph. And then for the second curve, I don't know if you can see it. So here's our second graph, and we're near the intersection down there. Hit enter, guess, and then here's our other one, -4, 0. So when we write our final answers, remember we had 0, 12 as one of the solutions, and -4, 0 as another solution. So these are the two solutions we found by graphing. That's it for these notes. I'll see you in class for more practice.